All right, hello everyone. This is Maximizing FileMaker Performance. I'm Greg Lane. It's been an exciting day. I'm glad you've joined me for the next hour to talk about performance. I've got some good stuff here. I hope it helps everyone in some way. So let me tell you just a little bit about me, and then we'll get into the session. So I work for Skeleton Key in St. Louis, Missouri. We're a team of 12 certified developers. We primarily do custom development work for a variety of clients in the St. Louis area and beyond. I've been using FileMaker for a long time, love the platform, and it's been a big part of my career and my life for the last 30 years. I also wanted to mention that the topic of performance is something that Skeleton Key has been a part of for a while. So several years ago, Mark Richmond did a session or two at DevCon talking about WAN performance and some specific techniques and information that's important for building solutions that perform well over the network. So some of what I'm talking about today is kind of a continuation of that, but there's also some new ground we're covering here as well. So our agenda today is really about analyzing and understanding the performance of your solution in your environment. So I'm not going to tell you about the fastest way to do a particular thing, because it's really dependent on your solution and your server, your users, the data in your system, a lot of factors that you can't really compare one system to another and get exactly the same kind of results. So I'm hoping that I can share some ideas about how to test and analyze your own solutions so that you can get the best performance out of it that you can. I also wanted to mention that when I proposed this session, I proposed it as an advanced session, although the sessions are not really categorized this year, beginner, intermediate, advanced. So I think there's something in here for everyone, regardless of your level. But if you find that the content is really not for you, no hard feelings. Feel free to slip out and check out something else. I know there are plenty of choices out there. So our agenda for today, we're going to look at a few resources, talk about a few terms and concepts. I've got 4 case studies we're going to look at, some real-world examples that have come up with our clients in the last 6 or 8 months or so. And then I'm going to dig into a demo of Apache JMeter. And we'll see how the timing goes on that, but this is a tool that we're going to use for load testing. And hopefully that'll be a useful tool for you in your environment. I'm hoping to have a little bit of time at the end for Q&A. We'll see how the timing goes. Maybe just a little bit long, but I'll try and keep it within the time. Please use the microphone if you do have questions. A couple of things about what we're not going to talk about today. I kind of mentioned this, but we're not going to talk about the best way to do a particular thing. So is the while function faster than a looping script? That's not the kind of thing that we're going to talk about today necessarily. I'm going to show you how to test that and measure it, but we're not going to look at specific techniques or how to do those today. I'm also not going to talk much about some of the common FileMaker performance best practices. So there are a lot of concepts out there that you should understand if you're trying to build a solution that's going to perform well over the WAN or even in a local environment. So things like narrower tables, smaller found sets, server-side processing, simpler and smaller layouts, keeping your themes small and compact, smaller images, caching unstored calcs and summaries, using appropriate indexes, not indexing everything, but indexing the things that need to be indexed and trying to understand exactly what that means for your solution. So those are things we're not really going to talk about today. But I want to point out a few resources that will help you if any of those are unfamiliar to you or you just want to learn more about what's going on. There's some great resources out there. So if you go to YouTube and search for FileMaker Under the Hood, there's some really great sessions from previous DevCons out there that really dig into the fundamentals of FileMaker and how it works under the hood that will help you build better solutions. Last year at DevCon, Josh Orman did a session on performance tips for beginners. That was a great session that covers some of those fundamentals and best practices. That is available on YouTube as well. I'd encourage you to check out that session. And if you really want to dig deep, Nick Lightbody from DeskSpace.com has some great blog posts and some tools out there on his website that will really help you understand kind of what's going on under the hood in some of FileMaker server's performance aspects. This year's DevCon, There are 4 other sessions, at least 4 other sessions, I hope I didn't miss any big ones, talking about performance. So the first one was server monitoring with Zabbix. I believe that one was earlier this afternoon. I'm a big fan of Zabbix. We've been using it for about 9 or 10 months now, and I honestly sleep better because of our Zabbix server. So knowing that all of the servers that we're responsible for managing are being monitored, a lot of things take care of themselves automatically, and we get emails and text messages when there are problems that require our attention. So big fan of Zabbix. If you didn't attend that session, check out the slides or watch the video when it comes out. There's some great material there. There's another session tomorrow afternoon on developing solutions for the WAN first, optimizing for performance there. And then another under the hood session, a new one on FileMaker Server 18's performance features. So be sure and check that one out as well. And then on Thursday, there's another session on load testing FileMaker apps. And Justin's taking a little different approach than what I'm doing here. He's using completely different tools, but I'm sure it will be a great session and give you a different spin on how you might approach load testing. All right, let's talk about a few performance concepts. So response time, you can think of response time in a couple of different ways. One is from the user's perspective and their perception of how the application is responding. And that doesn't always correlate to the actual performance of the solution. So there are a lot of UI, UX kind of things that can help an application feel more responsive. And I mentioned that, but it's not really the focus of today's session. So we're not talking about those UI, UX techniques. We're talking about the measured performance, the objective performance of specific transactions or functions, and how to measure those and optimize those in your particular environment with your solution. So the idea of think time, when you're doing automated performance testing or load testing, think time is a delay that is intentionally inserted between test steps to simulate what the user would do. So if you think of a user who's taking an order from a customer on the phone, they're talking to the customer, and maybe they have to create a customer record, and then they're creating a new order record, and they're adding line items to that order record while they're on the phone. And so there are a lot of steps there, and there's a lot of delays. Like if you were just writing a script to do all of those steps, it would happen, almost instantaneously. But there's a lot of delays that can be happening there, and when you add all of those up, it allows you to support more concurrent users. So you think about that in your test plans when you're load testing to insert those kinds of delays. But you don't know exactly when those delays are going to happen. They're not going to be evenly spread out across all of your users all of the time. So you'll have times where the server is particularly busy because everybody's hitting it at the same time, just the way that things work out. So we'll talk a little bit more about think time a bit later. So load testing, I mentioned load testing, but this is really just simulating lots of user activity on a system and trying to test the performance of that app when it's under various amounts of load from users. Failure testing is kind of when you take the load test to an extreme. So what happens when you put so much pressure on the server that things start to fail? Whether the connections break or are dropped, the client crashes, the server crashes, all kinds of things can happen. So regardless of how simple or awesome your solution is, you can push it beyond its limit or beyond the limits of the hardware where you've deployed it. And in some environments, you have to be able to document what happens when there is a failure like that and understand what the risks are. One other thing I want to say about load testing is that we've had requirements from clients who may write out these really long, detailed specifications for a system they want us to build for them. And sometimes they'll say something like, the maximum response time should be no more than 3 seconds for any function that a user might do. Well, it's easy to demonstrate that on a local machine as you're doing development, that, yeah, everything's nice and fast. But what's going to happen when you actually get that into production? Maybe you've got 100 users or 200 users, and they're out across the WAN, wherever they might be. How are you going to demonstrate that this solution can really perform all of these functions under the expected load and provide the expected response time? So hopefully these tools will help you answer those questions. A couple of other concepts here about network bandwidth and latency. So there was a time when network bandwidth was a huge issue because people were trying to host servers on-prem and support remote users. Sometimes they had pretty slow pipes to the internet, especially their upload speed. These days, bandwidth is less of an issue in a lot of cases. It's still an issue at times, but it seems like less of an issue than it used to be. A lot of people have gigabit connections into businesses or into many homes these days. So the bandwidth issue is not as important as it used to be. About any, I don't want to make too many generalizations, but about any connection out there is going to support a decent FileMaker application, especially if you're hosting in a cloud where the pipes are pretty big. Network latency, on the other hand, is how you measure that response time between the client and the server. It's that round-trip time that it takes for the client to ask the server something and the server to respond back to the client. And there's a lot of physics involved in here that say that, it can only go so fast. You can only you can't improve on the speed of light. So when you send a signal through a fiber optic cable, it takes about 1 millisecond for that signal to go 125 miles. So if you've got a client that's 3,000 miles away from the server, the round trip there is 6,000 miles, and you do the math there, and there's, I didn't do the math in advance, but it's 50 or 60 milliseconds, something like that, just of the time it takes that signal to travel across the fiber optic cable. And then you've got a variety of routers and other things in between there that may slow down that connection further. So think about the network latency. If everything is on a local network, your server's on-prem, and everybody's got a wired gigabit Ethernet connection, you're probably looking at less than a millisecond of latency in most cases for your clients. But once you start adding wireless devices, or you have people coming in remotely, lots of things happen there, and the latency can quickly degrade to tens or hundreds of milliseconds of latency, depending on the connection. So if you want to measure the latency from a FileMaker client, I don't know if this is going to be very readable. Let me see if I can zoom in a little bit. But here's a quick calculation that you can use using the while function to calculate the latency between a client and a server from any FileMaker calculation. So essentially, the gist of this is the getUserCount function. So getUserCount essentially causes the client to send a request to the server to say, hey, how many users are connected right now? And every time you call that function, it's going to send a request to the server and get a response back. And so it's one remote call, happens very fast, and it's a very close approximation for the network latency between the client and the server. So if you've got a situation where you've got a feature of your solution that you know is going to perform poorly when somebody goes out on the road and they try to run it remotely. Let's say Bob goes on vacation, and he's normally in the office working from a wired connection, but he goes on vacation and he tries to run the cost analysis report or something while he's on vacation on the road thousands of miles away, and you check before he runs the script and check the network latency, and you see that, hey, there's 150 milliseconds of latency. That report is going to be super slow potentially because of what's going on there. Maybe you haven't had a chance to optimize the report. Lots of things could happen there. This is a quick way to test the latency between the client and the server, display a message to the user to tell them that they can't run this right now, get back to their vacation, and run it when they get back to the office. So that's something you can use, nice and simple. So let's talk about logs. Every server creates logs of its activity. So there's, whether it's just the Windows operating system, the Mac operating system, a database server, a web server, every server creates lots of logs. FileMaker server is no exception. There are 3 key logs for looking at performance: the stats log, the client stats log, and the TopCallStats.log. The stats log is all about aggregated server statistics. So every 30 seconds, it writes a record to this log that says, how many kilobytes of data have been written out from the server, how many have been read into the server, how many remote calls have there been, what's the wait time or the I/O time cost of those remote calls during that 30-second period. You also get counts of the number of users connected and all of that stuff. So there's some really great information in that stats log. The client stats log is disabled when you start up FileMaker server. So it's always turned off when you start up FileMaker server. But when you enable it, it will write an entry to the log for every user who is connected during that 30-second interval. And you'll get lots of those statistics about that specific client and their experience connected to the server during that 30-second period. The TopCallStats.log is also disabled when the server starts up. When you enable that, you're going to get up to 25 of the slowest remote calls that occurred in that 30-second period. So that's a really useful thing, and it's a really granular look at what's happening kind of under the hood in FileMaker for each remote call between the client and the server. We're going to look at some examples of these logs in a little bit, and I'll make a few other comments about some of the things that you'll find in there. I've got slides. If you're following along with the slides from the community forum, I've got slides in here that detail the information that is in each of these logs. I'm not going to spend much time on these here because I'm hoping to look at some actual examples of these logs. But the information is here. This is the stats log and the specific information that is included in the stats log, the client stats log and the information that's included in there, and then the TopCallStats log. Again, that's the slowest 25 remote calls that occur every 30 seconds when that log is enabled. Let's talk about a couple of tools. So for load testing, the tool that we're going to be looking at today is Apache JMeter. That's an open source software that you can write test plans and run that against a server and measure the results. There's lots of other ways to do load testing, though. You can write scripts in FileMaker and run that from a FileMaker client, FileMaker Pro, FileMaker Go, and check the performance of that in a variety of different ways. Those scripts can call perform script on server, so they can actually kind of simulate extra users from a single machine. You can also do manual testing. If you've got access to lots of computers, you can set up FileMaker Pro to run a script to do a certain set of actions and measure the time it takes to do that, look at the stats on the back end, and see how it goes. JMeter is just another way to put a load onto FileMaker server or really any web server, anything that you can access through the web or JDBC or a variety of different things can be tested with JMeter. Network link conditioner, if your server or your client that you're testing from is a Mac, Apple has a utility that comes with Xcode called Network Link Conditioner. This can be a great way to simulate different network environments. So you can put a limit on the upload and download bandwidth for that connection from that machine. And you can also adjust the latency. So you can increase the latency. You can add packet loss. So if you want to simulate a poor quality connection, you can use Network Link Conditioner in your testing to do that. A few different tools for monitoring what's going on the server. So beyond the logs, we can use the performance monitor and the resource monitor on Windows for looking at the CPU activity, the disk activity, network activity, memory, how much memory is free or in use. For the Mac, we've got Activity Monitor, or from the terminal, you can use Top or NetTop to get lots of details about what's going on the machine there. If you're using FileMaker Cloud on a Linux server, you can SSH to that instance and use Top to get more details about the CPU and memory usage on that server. If you're hosting at AWS, AWS has a service called CloudWatch, which allows you to see detailed monitoring information about your servers that are running at AWS. If you're hosting somewhere else, they probably have similar tools like CloudWatch that allow you to see detailed information about CPU usage, memory, disk activity, network throughput, and all of that stuff that you can monitor very easily. And then for any of these environments, you've got the FileMaker admin console that you can use. There's some basic charts in there that show you CPU and memory usage, network activity. And then we mentioned Zabbix earlier. Zabbix is a great tool. I'm going to show you some examples that come from Zabbix today, and hope that you find those useful. So I've got 4 case studies to talk about today, and these are from actual examples with clients that came up. So this first one, the case of the suspicious slowness. The client has a FileMaker Cloud instance. It's a solution that we've built part of, the client has continued building, and but we continue to host it for them. And one day the client reports to us, hey, the database is really slow. So we looked into it, we did some basic troubleshooting, and didn't find anything specific, but we suggested, hey, maybe we should try a larger server instance. He was on a T2 medium, and we decided, okay, we'll switch it to a T2 large. It's easy to do that with FileMaker Cloud. So we just took it down for a bit, brought it back up as a T2 large. The client runs his test again and says, hey, it's still slow. And this time he gave us a sample script of what he was doing that he thought was particularly slow. So we look at the sample script that he gave us, and it's just creating 1,000 records in a loop. He was trying to implement a virtual list technique, and he was just creating 1,000 records. And he says, when I run this on my machine, you know, it's instant. It's less than a second. It just happens. But when I put it on the server, it takes 5 minutes for this thing to run, to create 1,000 records. Well, okay. So we look at the network latency that he had. He reported to us that his network latency from a speed test site was 30 milliseconds. All right, so those are all clues about what's going on here. And some of you already know what the problem is, but let's look for a little more evidence here. So we looked in the, I don't know if that's readable up there or not, but I'm going to zoom in a little bit and hope that that helps. So we looked at the stats log, and specifically we found the time in the stats log where the client was running his test. And we see every 30 seconds, there is a count here of the remote calls per second that were occurring for that client. It happened to be at a time when there were no other users connected, so we could see very easily how many remote calls were occurring during the script that he was running to create 1,000 records. So we add these up and we see, hey, there's 147 remote calls per second. And let me interject here that there was something I learned not too long ago, within the last year or two. I had this misperception about the stats log and this particular column to think, okay, in this 30-second interval, there were 15 remote calls. Well, that's not what the column is titled. It's remote calls per second. So when you want to know how many actual remote calls there were in that time period, you have to multiply it by 30. So there are 30 seconds in these intervals. So there are 147 remote calls represented here in this time period. We multiply that by 30. So there were really 4,260 remote calls happening to create those 1,000 records. So you can see from that in his particular system, it took 4 remote calls from the client to the server to create a single record. His actual network latency was about 60 milliseconds. So that means that it took about a quarter of a second, 250 milliseconds, or about a quarter of a second, to create a single record. That means another way to think of that is 4 records per second. And so suddenly it was making sense that it's just a latency issue. So we explained to the client, you know, here's what's going on that's with the latency of your connection. And 60 milliseconds is not that slow. You'll run into far worse latency out there. So it's important to understand the effect of taking a solution like this and moving it off-premise and connecting remotely and what can happen there. So the solution here in this case was to introduce the client to perform script on server so that he can run that script with all of the real activity happening just on the server. And suddenly the script was almost instantaneous again. And he was very happy with that. All right, so the next case here that we're going to talk about, the case of the curtailed CPU. So this is a client also on FileMaker Cloud, a T2 large instance. The client collects medical research data and does analysis of that data. And so there's some heavy processing happening there, but not a lot of users. So there's just a handful of FileMaker Pro users, a handful of WebDirect users who connect to this particular solution. Well, there was one day when we started receiving a lot of high CPU usage alerts from this server over a period of a couple of days. And so we're looking into the server, we're monitoring it, seeing what's going on. Then on the third day, the Zabbix was showing that the CPU utilization had gone to 100%. And that's never a good situation. The good thing, though, was that the client wasn't really complaining about it. We didn't hear from the client at all or the users. So things from their perspective seemed okay. But we looked at the stats on the server and knew that there were problems. So let's zoom into this and look at the evidence a little bit about what's going on here. So this is CloudWatch monitoring from AWS. So we're looking at CPU utilization over a 2-week period, and these are averages for 5-minute periods. So you can see normally, there are these spikes in activity that go up to 50% or even 100%, depending on the activity that the user is doing at the time. There's some scheduled scripts happening, and the clients can also click buttons that run additional services on the server, so the CPU utilization can be fairly high at times, but you get these spikes and then it drops right back down to normal. But then something unusual happened here on this day, and this is the period that we were seeing in our monitoring alerts. When we were seeing these spikes come up to 100% here, and there were several of these over that 2-day period, and we look at this and it's never going back down to 0. So there's definitely a problem here. But then, after a day or so, maybe 24, 30 hours, something like that, it kind of drops down a little bit, and we don't see any more spikes to 100%. So this is from the CloudWatch monitoring CPU utilization perspective. Let's look at a different perspective. So this is the CPU utilization graph from Zabbix, which is telling a little different story. So it's the same kind of information, and you can kind of see the same peaks and stuff, but I guess let me point out a couple of things about the way Zabbix draws this chart. So all of the blue area here is essentially user time. So in FileMaker servers processes count as user time from Linux's perspective. So any blue area you see here is just CPU activity caused by a FileMaker server or other user-based processes on the server. All of the green area is idle time from the server's perspective. The CPU is idle. Okay, we get over here to this this area of interest and see the user time went up to 50% and kind of stayed there with additional spikes that were happening now and then. But then all of a sudden we're seeing this pink stuff here. What's going on with that? So this is referred to in Linux as steal time or stolen CPU time. And that happens when the physical host is not allowing the CPU to work at its normal speed. So remember, this is a T2 instance, and all of the T instances, so whether it's T2, T3, T3A instances, Linux or Windows, on AWS, have this concept of CPU bursting. So they have a baseline performance for the CPU, but as long as you have CPU credits, the CPU will burst to a higher speed for a period of time, and it's constantly replenishing those CPU credits. But if your CPU is running at 100%, then it's going to consume those CPU credits faster than it will replenish them. And so you end up with the stolen time from the operating system's perspective. And eventually we got to the point where this is where we hit 100% total CPU utilization when just things went to the next level here. So what we found when we looked into this was basically there was a WebDirect user who had started a script, and for some reason the web publishing engine continued running that script after the user had disconnected and was gone, kept running for days and days. And I won't get into the details of why that script kept running the way that it did, but the solution here was to restart the web publishing engine. And then quickly the CPU credit balance recovered. So the next chart here is just looking at that CPU credit balance from, this is again CloudWatch, monitoring details, and we can see that normally that CPU credit balance is full, about 850 credits on a T2 large, I believe, is the limit. That occasionally dipped down just a little bit by a few credits, but during this period of heavy activity, it dropped down all the way to 0, and that's where the performance really started tanking. So we stopped and restarted the web publishing engine. The CPU credit balance started to recover, and then a user probably ran some fairly heavy activity, and we crashed back down to 0 available CPU credits just briefly, and then things finally recovered back up to a normal level. So one other slide about that. So this is just kind of illustrating the combination of the CPU credit usage versus the credit balance. And this is all of the T instances at AWS. So as you use CPU credits, your credit balance will drop. Once you get to 0, your CPU effectively gets throttled back to that baseline performance. Depending on the size of your instance, that baseline performance can be quite slow. It's going to be much slower than you're used to. When you start up a T instance, they come with a full balance of CPU credits. That helps it start up faster and get into things faster. But once you run out of credits, the performance will fall off. All right, so the case of the missing memory. So this is another FileMaker cloud for AWS, T2 large instance. This is a very small company that does financial services. They have lots of scripts. In this case, this solution was built several years ago and hosted on FileMaker Cloud since, I believe, version 1.15, back when we were not able to schedule scripts via the FileMaker admin API. So we were using a robot machine to connect to the server and basically kick off these server-side scripts at different intervals. There were some that happened at various times a day and then throughout the day. So occasionally users would report really slow performance in FileMaker Pro. And it didn't happen very often. Their usage was, followed pretty steady patterns on most days. But occasionally it would just spike up and it would be very slow from their perspective. But most of the time, the CPU utilization rarely got up to 20% for any sustained period of time. So if we look at CPU utilization here, you'll see just a few of these little peaks in here at different times. And this is a 90-day view. So this is a long view of what's happening on this particular server. This chart is coming from Zabbix, which is great because it lets you look back over a long period of time, up to a year, the way we have most of our templates set up. So you can look back at server statistics for a long period of time and see what's happening. There's something else interesting here, and we'll get to this in a little bit, but you'll see most of these little peaks are not blue. So they're not user activity from FileMaker server processes. So there's something else going on here. So let's take another look at a typical day in the life of this server. So I can zoom in on this particular chart down here a little bit. Again, this is a 24-hour period, just one of these little slices of what's going on here. And I can tell a little story from this based on, every day at 3 a.m., there's a script that runs that's fairly heavy. It peaks the CPU, one CPU at 100% on one CPU, 50% overall. And then there's not much happening until 6 a.m., and then there's a variety of scheduled scripts, some that happen on the hour, and then some that happen every 10 minutes. And that's what all of these little lines are that you see across here. Occasionally, the user will kick off something, or there's another scheduled script that happens at 3 p.m., and then all of those schedules stop running late in the day, 7:30 p.m., something like that. All right, so let's look at this next chart. Again, this is from Zabbix, looking at 90 days, and this is available memory on the server in that 90-day period. So notice these big peaks. So this machine has about 8 gigabytes of memory. It's a T2 large. And after the server restarts, it has a little over 5 gigabytes free of available memory. But then as those schedules continue running over several days, you can see the available memory starts decreasing and decreasing and decreasing. And when we get down into this valley here, things start going badly. And then we would restart the server and it would get back to normal, and then the same pattern would happen every day. And eventually we get down here, we wait too long to restart the server, and the client will see one of those instances where they're seeing slow performance on their machine. So what's the root cause of what's going on here? Because the load is not really changing on the server. But let's look at, drill into the CPU utilization on one of these specific days in here. So a 24-hour period looking at the CPU utilization. And we'll see, the user activity from FileMaker is pretty steady through here. There's nothing terribly unusual. But then you start to see this yellow mountain building underneath the surface here. And if we drill into the key here, we can see that yellow color indicates CPU I/O wait time. All right, so that basically means that the CPU is waiting on storage to get data into memory. And so most of you are familiar with the concept of virtual memory or paging. Windows does this, the Mac does this, Linux does this. And basically, it's a way to use your storage space as additional memory. But it tends to be slower. Well, on a FileMaker Cloud instance, there's a dedicated 8 GB volume that's used for swap space for virtual memory. And the way that the CentOS Linux operating system is configured, as soon as the free or available memory goes below 30%, Linux will start swapping things to that swap space. So normally that's fine, but the performance of an EBS volume, that's the type of storage that we have at AWS, an EBS GP2 volume that is less than 34 gigabytes has a baseline performance of 100 IOPS. That's an input-output operation per second. It's a way to measure the performance of a disk. So typical SSD is going to have tens of thousands of IOPS available to it. But a small EBS volume has a baseline performance of 100 IOPS. But the good news is that they have a credit balance, much like the T instances do. There's a bursting capability that they have where they can burst up to 3,000 IOPS for a period of about 30 minutes, depending on the credit usage there. But once you exhaust that credit balance, you're back to the baseline performance of 100 IOPS. And when we're using that for swap space, 100 IOPS is not much. I mean, it takes me back to the days of using a floppy disk on an old Mac that's, you're doing the floppy shuffle. And it's not quite that bad. That's an over-exaggeration. But you get the idea. 100 IOPS is pretty slow. So that's 10 milliseconds for every disk operation to occur there, if you think of it that way. So the solution here is really to get rid of that robot machine that was connected. So the great thing about FileMaker Cloud instances is they have an auto maintenance feature which will restart the server every night between midnight and 1 a.m. So, but they won't do that if there is a client connected. So because we had that robot machine connected 24/7, it was preventing the auto maintenance from kicking in and automatically restarting the server. So we finally used the FileMaker admin API to schedule those scripts. We had some plugin issues and finally got things resolved there and got into a pattern where that server was regularly rebooting every night between midnight and 1 a.m. And then we always had plenty of available memory. We never got below that 30% threshold, and so the swap space was almost never used at all. And the client has not experienced any more of those days where the performance of their solution was really bad. All right, so the next case here is the case of the Dapper DAPI developer. So this is a large retail client, an on-premise server, virtual server, large, well-managed IT infrastructure. This is a product information database with hundreds of thousands of SKUs in it. It's not the company's main ERP system. This is a system used by the Creative Services Department for the organization, where they're writing copy for products, writing copy for the website, for catalogs, for weekly mailings. They're taking pictures and managing those assets in this system and so forth. And so there's information in this particular FileMaker database that doesn't exist anywhere else in the organization. And it's valuable for certain purposes and the people who need it. So the local people who are using it, they're all FileMaker Pro connections. They're on a local connection. It's nice and fast, and it works fine. But they had a vendor partner, I believe it was a printer, who needed access to information about the status of certain products, or maybe they needed to access the updated copy for certain products at different times. And so they asked for a way, so, hey, how can we get to this data? We know you've got this data. The vendor was outside of the company's network, and so they didn't just want a FileMaker Pro connection to the system to be able to access things. They wanted programmatic access to this data so that they could update their systems, their own database, with the information that was in the FileMaker system. So the FileMaker Data API was the solution that we came up with to allow them to have an easy access to this. Their developer was comfortable with REST-based interfaces. And IT was comfortable with giving them access on port 443 to the data API, so everybody was happy. So the developer takes this and he goes off and builds his program that's going to update their database based on the FileMaker data using the data API. And a few days later, we got an email with the subject line literally that said, "I think I killed the dev server." So we looked in the logs and we found that, hey, he created 60,000 data API requests one night. And this was in a period of maybe 4 or 5 hours, something like that. So the script that he wrote was basically looping through all of his all of his products, looking up that product in the FileMaker database, and updating the information and status and stuff in his database. Well, we found that he was creating a new session with the data API for every product that he was looking at. So and that may seem like a tidy thing to do. You create a session, you do a little bit of work for that particular product, and then you close the session, you move on to the next product. Well, the problem is there's a lot of overhead involved in creating a connection with the data API. And so let me show you a few examples of what happens there when you connect through the data API. And this is similar for any type of connection through any of the APIs. There's this overhead that occurs when you create a connection. So I'm going to try and zoom in on this a little bit. The details aren't too important, but I'll point out a few things that are going on here. So this is data coming from the TopCallStats.log. And basically, we used an idle server, and we were not using this particular client's database. We just used a starter solution, the content management starter solution, and hosted that database. And we made a call through the data API to log into the data API. So we look at the TopCallStats.log, and these are the calls, the remote calls that occurred during that login. And so there's a few things that are important to understand about what's going on here. Normally, when you get these log entries out of that TopCallStats.log, they're sorted by total elapsed time, with the biggest total elapsed time at the top. In this case, I've sorted these by the start time. So I grabbed those entries, sorted them by the start time, so we can see sequentially what happened. And there were less than 25 calls, so we were able to see exactly what happened during the data API login. So let's look at a few details here. And kind of the core of this is kind of what's happening with the operation and the target that's happening for each of those remote calls. And it's important to understand that these remote calls are not from this developer's program to FileMaker server. These remote calls are between the web publishing engine and the database server. So when we look at these remote calls, some of these are very, very fast. And in fact, all of them are very, very fast. But there is some activity going on here. It's important to understand the pressure that you're putting on the database server when you're making these types of connections. So we can see there's a request for the file status, and then requesting notification, the login happens, and then we're downloading stuff. All the rest of this is we're downloading stuff from the database server to the web publishing engine. We're getting privilege information, we're getting table information, value lists, custom menu sets, scripts, layout information, themes, privileges, and finally a master record list for the table that we happen to be on. And if we look over here at the network bytes out, we can see that there's quite a bit of activity. So just the theme for the starter solution is 103 kilobytes. So that's quite a bit of data that's happening. Every time a user logs into the data API, that data is being transferred from the database server to the web publishing engine. And we can see the elapsed time here. When you're looking at these numbers out here, elapsed time, wait time, I/O time, these are in microseconds. So a microsecond is a thousandth of a millisecond, or a millionth of a second is another way to think of that. So these are all happening very quickly, but these things add up over time. When you do it 8,000 times, it certainly adds up. So we did a little math here to calculate this, and so there's a total of 194 kilobytes of network traffic going out from the database server. If we total up the elapsed time of these calls, it's just less than 1 millisecond. But if we actually calculate the difference between the start time and the end time, it's closer to 5 milliseconds. So there's different ways to look at that. So there's this overhead that's happening to construct the request, send the request to the server, get the response back from the server to the client. That's not counted in the elapsed time of each of these remote calls. So when we actually do the remote connection to the data API, we use JMeter to help measure this, and when we were connecting to a local server on the same machine, JMeter was running on the same machine as the database server and the web publishing engine, all a single machine deployment. It was about 13 milliseconds from the client's perspective for that connection. But when we tested this over a WAN, and this was the scenario with this particular client, they were coming in from a few states away. I don't know exactly what their latency measurement was, but when I tested with about 65 milliseconds of latency, we found that it took about 333 milliseconds to log into the data API. And you can infer from that that there are 5 round trips from the client to the server that are happening when you log into the data API. Some of that is in the SSL negotiation between the client and the server. So when you establish an HTTP connection from the client to the server, there's this SSL negotiation that goes back and forth between those machines, and then you finally get to the actual request that's happening there. So, but you're essentially sending 5 round trips from the client to the web publishing engine, and then you've got all these remote calls happening between the web publishing engine and the database server to think about that. If we look at another example here, so once we're logged in, let's say we want to create a new record. So these are the remote calls that happen when you create a new record in this particular content management sample file in this particular environment. So we can see we're downloading with a lock, and we're downloading lists and creating the record. We're downloading field definitions, probably updating a serial number here. We're uploading that list back to the server, and then we're finally committing that record. And we can look at and see that the amount of data that's transferred between the database server and the web publishing engine and what's going on there. So I've got the calculations here. It's less data that's happening, just creating that simple record in this case. But the sum of the elapsed time is actually a little larger, about 1.5 milliseconds. And then the total actual time that this occurred was just over 4 milliseconds. Measuring this from the perspective of the REST client, on localhost, it was about 18 milliseconds. And with 65 milliseconds of latency, we were seeing 259 milliseconds of elapsed time, about a quarter of a second for that request to create a new record once we were already logged in with the data API session. So you can infer from that there are basically 4 round trips occurring from the client to the server for that action to occur. All right. So let's talk about Apache JMeter. How am I doing on time? OK. So we'll move through this fairly quickly, but I want to introduce this tool to you and show you a little bit about what you can do with it. And I'm going to point you to some other resources about how to implement this on your own, and hope that that's helpful. So Apache JMeter, it's open source software used for load testing. I pulled some of this language from their website, load testing functional behavior and measuring performance under different load types. So it's essentially a really flexible tool that's programmable, but you can start out pretty basic. It's kind of point and click to get started with it. You create your test plan. You configure test parameters. How many simulated users do I want to use? How many times do I want them to run each test? That sort of thing. Then you run the test. Then you can do some analysis of those results. Let's see what happened. Let's look at our logs. Let's look at the performance metrics that are available on the server and see what's going on. Then we can make a change to our solution and then repeat the tests and see if that change helped things or did it make things worse. Maybe that change is, you're testing on a FileMaker server 17 server, and then you repeat the same test on FileMaker server 18 so that you can be assured that the performance is what you expect it to be when you deploy this new server. So there's a lot of things you can do here. So let's look in a little more detail about what's going on here. And I should say, I started using JMeter about 6 years ago or so. We had a fairly large web application. It used PHP and Postgres and some other tools. FileMaker was involved, but not directly in the production server. of what we were doing there, but it had hundreds of millions of records. And the web users were essentially doing searches or queries on this data using a very FileMaker-like syntax, kind of the find by example interface that FileMaker would provide. And so we needed to make sure that the servers that we were using, the queries that we're using for the database, were going to perform okay in that environment. So we used JMeter to do a lot of automated load testing of the servers so that we could appropriately size those servers and what was going on there. So more recently, I picked up JMeter again and started using it to test some of FileMaker's APIs to understand better the performance characteristics of each of those for different systems that we were analyzing performance on. All right, so let me jump into this demo. So I don't know how the network experience has been for you here at DevCon this year, but I was having some problems the last couple of days. When I tried to run some of these tests while connected to the Wi-Fi, things didn't go so well. So JMeter creates a lot of connections, and that's not always friendly to routers and networks. So what I ended up doing last night was set up a little local network between two machines, and I recorded the demo that I was hoping to do here live today. So you'll get the same effect, but it's going to be a little bit different. But let me introduce, before I play that video, let me introduce what's going on in JMeter a little bit here. So I've got this test plan, and I'll give you a link for this in just a minute. It's out there on GitHub. You'll be able to grab this test plan as a starting point to use to build your test plan for your solution. There's a feature here that, let me try and zoom in on that a little bit. So there's a section here where you can define some variables that are used in various places in this test plan. So we can define the address of our server, the DNS name for the server, the database name we're going to connect to, the layout name that we're going to connect to, the table, username, password, all those various pieces of information. So I built this around the content management starter solution, so that's an easy way to get started. But ultimately, you would want to take this template and tailor it to your particular solution and your environment and write a test plan that is representative of how your users are connecting to your server. And you may say, well, all of my users are using FileMaker Pro. They're not using these various APIs. Well, the interesting thing, though, is that from FileMaker servers, the database server's perspective, a remote call is a remote call. When you log in through the data API, the activity is very similar to what happens when you log in through FileMaker Pro. And you can look at the TopCallStats.log and see what's going on there. Now, FileMaker Pro has the advantage of doing some caching. So more recent versions, since version 15 or so, do more local caching of data. So you end up with a lot fewer remote calls happening, which can really help performance. But the web publishing engine doesn't always have those same kind of optimizations for the connections that are happening there. So this is primarily a way to throw a load at the database server and understand what's happening there. So if you look at the template over here, we can see that there's several things happening here. We're doing the data API login, so there's a request here to do that. And then we've got different thread groups for the different APIs. So the data API, we've got steps here to find records, to create records, to update a record, and then to execute a script via the data API. So all of these steps in the plan here, you can dig into and find out exactly what's happening. We're doing an HTTP post. Here's the endpoint that we're hitting. We're incorporating our variables from that user-defined variable section, so you don't have to hard code these in all these places. And then here's the JSON object that we're sending to the data API for that. So you can see what's going on there. So I'm not going to go in detail through these because we just don't have time. But there are similar test threads here for the data API, JDBC, and for the XML API, so that you can test all these things, creating records, finding records, editing records, and running scripts through each of those APIs. And then finally down here at the bottom, and this is where you're going to see the results. So there's a summary report that you'll see. There are also different types of graphs, and there's a whole library of things that you can add to your test plan here to really tailor this to exactly what you want. But these are some good starting points so you can see the details of what's happening in your results. All right, so let me get over to this video. It takes about 1 minute to play, and I'll try and narrate what's happening here So this is just a slightly modified version of that template. I'm just going to show you here that in each of these thread groups, we're simulating 50 users running each test 10 times for each of those users. So we're doing that for the data API, the JDBC API, and XML. And now we started running the test here, and we can see that the samples are being created. All of these requests are happening. The records are being generated. You could be connected through FileMaker Pro and see that, hey, there are new records being created or updated while this test is running. So the data API is finished. The JDBC connections are happening now. They are almost done. They finish, and now we're on to the XML API requests that are happening here. So those are almost done, and then we can take a look at the stats that are created here from this. So we can see the average amount of time that each of these requests take. These times are in milliseconds, so you can understand what's happening there. This was, again, a local connection, an Ethernet cable directly from one MacBook Pro to another MacBook Pro. So kind of a best case scenario on latency and disk speed and CPU and everything there. But you can run the same test on a cloud-based server. You can just point it at that cloud-based server. And in fact, I'd hoped to do that, but there just end up being too many errors when I run that type of test to a remote server on this particular network. But you can see the average amount of time that these requests take, the minimum amount of time, and then the maximum. And there's some interesting things going on here with this particular solution and this particular environment. We get to a point where some of these data API requests were taking about 1 to 2 seconds to occur as a maximum. So they were often very fast. 9 milliseconds was the minimum, but it ranged up to just over 2 seconds. Whereas the XML API was often faster in this particular environment. Again, don't take this to mean that the data API is slower than the XML API. It's all about your solution, your environment, and how that's going to perform. And I promise you it's going to be different. If we had connected to a cloud-based server, you'd see very different results in that environment. You'll also notice here, one other thing I was going to point out is the amount of data that's transferred. So I try to make these tests really similar to exactly what they were doing. So when we're editing a record, we're editing the same type of records, or when we're finding records, we're limiting that found set to 5 records each time, that sort of thing. But the amount of data that gets transferred with the XML API is much larger than the data API. The data API is much more efficient. So if you've got a remote connection from your client software to the web publishing engine, it's going to move a lot less data, and that is probably going to make things faster, but just because of the less data that's being transferred in that environment. But again, you've got to test your own solution. My results really don't mean much for your solution. All right, so let me show one other thing here, and then I hope I can take a couple of questions. So I wanted to show you a few of the logs. So if you just double-click on one of these logs, I've got a collection of these logs here. If you just double-click, on a Mac, they're going to open in console. But it's really hard to read these logs. Even if I zoom in here, it's really hard to understand exactly what's going on here. This is tab-separated data, and it's just really hard to follow in this view unless you just know exactly what you're looking for. So a much better way to look at this is to either import these logs into FileMaker would be a great way to go, or you can just drop them into a spreadsheet like numbers, which is what I'm going to do here. We open those up, and here's the stats log, and it puts things nicely into columns and allows us to see the network kilobytes per second and lots of information from the log here that you can search on. You can sort these columns to see exactly what's going on if you want to. Lots of things you can do with that. Similar with the client stats log, just a quick look at what's going on there with the client stats log, as well as the TopCallStats.log, and you can look through the details of what's happening in there. So try to use an appropriate tool. Sometimes I use just a text editor that has where you can set the tab stops, and then it's much easier to see what's going on, so you can copy and paste from console into that text editor, and it lines things up properly under the header and makes it much easier to see what's going on. All right, so here's the link to download that JMeter template. So it's on github.com/skgreg/fm-jmeter if you want to grab that. JMeter is available at jmeter.apache.org if you want to download that. At this site on GitHub, there's a README there that tells you how to get started, how to configure your database, so it's got the appropriate extended privileges and the information that you need there. I did make some updates to these slides, so I will get those updates posted. You'll be able to get to those through this link. I'm literally at 3:45, but I would be glad to take a few questions if anyone wants to stick around. But thank you so much for sticking around for this. I really appreciate it.